In this tutorial, we are going to talk about the introduction to static equilibrium. So I've got two interesting questions under this topic. So the first question is find the FR1 and FR2, but from the diagram is FT1 and FT2 if the object is at equilibrium and the weight is 600 Newton. Now, the basic idea behind static equilibrium is that the summation of all the forces in x direction, when we add all the forces in x direction, the net force is 0. The summation of all the forces in y direction is also 0. The summation of all the torque is also what? 0. But for this video, I'm not going to explain what torque is. But for now, we should just know that torque is given by force times distance. Okay? But I'm going to explain about the other type of static equilibrium questions which involve torque. For this video is only specifically for the summation of all the forces in x direction and the y direction. Okay, but these are the conditions for an object to be at a static equilibrium. The summation of all the forces in x direction and the summation of all the forces in y direction is supposed to give us 0, and also the net torque is also 0. Okay, so for this one we'll only focus on those two, but I have first to explain something. Under static equilibrium, if you have been given, you are supposed to use those three conditions. But under static equilibrium, if you have been given a question and that question it only have angles, like in this case, we are only dealing with the angles, the direction. In that case, we only use these two conditions. If you discover that you have got a problem under static equilibrium and you have been given only the direction, there is no any angle, in that case we only use the summation of all the torque. If you have got the combination, if you have got an object, a static equilibrium problem, which involves we have got an angle, at the same time you have been given the distance, you use the combination of the torque and that. But for now, we only focus on two things. The first part, where we're only going to be talking about the summation of all the forces in x and in y direction. Let's analyze what we have here. This is our diagram. So this is the weight force which you have here. So this is FT2. Now this FT2, to support FT1, is going to have the x component and the y component. Therefore, I'm going to say FT2 will have FT2x and FT2y. Then, one thing we have to understand here is that according to the rules of angles, if I have z, the angle which is there is the same as the angle which is there. In this case, I can clearly see that this is forming a z. Therefore, the angle which I have there is the same as the angle which is going to be there. So I'm expecting to have 50 degrees as well there. Okay. So now let's start with the summation of forces in x direction. So the summation of forces in x direction, when we add them, they're supposed to give us 0. What force do we have? We have Ft2x pointing in this direction, which is positive. This is pointing in that direction, I'll say minus Ft1x. Since the net force is 0, I'll replace this with 0. So I'll put 0 will be equal to Ft2x minus Ft1x. If I shift Ft1x to the other side, it's going to be Ft1x will be equal to Ft2x. Using SOHCAHTOA, I can clearly see that if we come to sine for Ft2, sine theta will be equal to the opposite is Ft2y divided by the hypotenuse is Ft2. So meaning my Ft2y will be equal to Ft2 sine theta. Okay, meaning that the one for cos is going to be in x-axis. So meaning, so for this one is in the x-axis is going to be ft1 cos theta. Okay, so now this one ft1 cos theta, what we need to understand is that we don't have an angle, so I'll just leave it ft1 just like that because I don't have an angle. ft1, that's all. Then this one now is going to be ft2, I'm supposed to say ft2 cos what? Cos the angle. Now the angle in that case is 50 degrees. Since I want to find ft1 and ft2, in this case there is nothing that I can do. There's nothing that I can do, so I'll call this as equation 1. I need the second equation for me to find ft1 and ft2. So I'm going to rewrite this one here to say the first equation that ft1 should be equal to ft2 cos theta. Now theta in that case is 50 degrees. That is my equation 1. Let's go to y-axis. The summation of all the forces in y direction, the only force we have in y direction is this force pointing upward and the weight force. So I'll say this is pointing upward is going to be plus Fty, then weight force is pointing downward minus the weight force. If I shift this weight force to the other side, this will be equal to 0 since we know that the net force is 0. We'll have this. Then it will be the weight force will be equal to Ft2. Now Ft2 in y-axis is going to be sine theta. It's the same as I say Ft2 sine theta is equal to the weight force. Now we know that is 600 newtons. Okay, or I can just say 600. The theta is 50, so in that case allow me to put just 50 direct. I want to find Ft2. I can divide both sides by sine 50, even here by sine 50. So I'm expecting my Ft2 to be equal to 600 divided by sine 50. So Ft2 is giving me 783.24 Newton. And for use here, we can clearly see that the answer which we have been given is 783. So that is the answer for Ft2. Since we said that Ft1 is equal to Ft2 cos 50, where there is, I can just get this and say, where there is Ft2, I'm going to replace with, where there is Ft2, I will replace with 783.24. Then cos 50 degrees. And Ft1 is going to be 783.24 cos 50. I'm getting 503.46 newtons. Now here is also 503. They just, the whole number now here is just 503 newtons. Then here is 783. So that is it for the first question. So we need just to understand the basic idea behind these three conditions which I've given you. So if in this case we don't have distance, that's the reason why I've only used the summation of forces in x and y direction only, and I'm able to get the answers. So let's see the next question. So the next question is saying, in the figure below, the pulleys are frictionless. The pulleys are frictionless and the system hangs at equilibrium. If W1 is equal to 200 Newton and W2 is equal to 260 Newton, find the value of W3. Now, in this case, you can approach this question in two ways. I also don't have the distance, meaning I'm not going to use torque. I can only use the summation of forces in x direction and the summation of forces in y direction. As simple as that. Now, if I want, I can say, I'm going to call these buckets which you have here. Let's denote this one to be T1 this one to be T3, and this one to be T2. So what we should know is that FW, what we should know is that FW1 is the same as T1, then FW2 is the same as T2, then FW3 is the same as T3. So when we find the tension, I'm going to be using the tension. It's the same as finding the what? The FW1, FW2, and FW3. Because this is supporting what? The tension force here. This tension force is same as that one because it is connected to one rope. Okay. The next thing we have to understand is that is either I have to resolve this one now. So I'll say, what I'm going to say is I can either put this one to be like this, okay, then I put it there. So I'll say this is T3x, this is T3y. Now again here I'm going to say x component and the y component is also there. I'll say this is T2x and this is T2y. One thing we have to understand here is that this is the line we should have. The angle from this point all the way to that point is 90 degrees. So to find the angle which we are going to use here, I'm going to say 90 minus 50. That is going to be 40 degrees. Then here I'm going to say 90 minus 35. Then I'm going to have 55 degrees here. So I'll start. The summation of all the forces. In this case, I know that my T2x is going to be replaced by T2 cos the angle which is 40 degrees. Then my T2 or my T3x will be equal to, using cos, is going to be T3 cos 55 degrees. If I go in y direction, my T2y will be equal to T2 sine 40 degrees. Then my T2 what? My T2 or my T3y will be equal to T3 sine 40. Or sine what? Sine 55, sorry. Sine 55. This question is direct because we've been given two things. I think I can only use one. If I go and say the summation of all the forces in x direction. In x-axis, the positive x-axis, we have got T3x minus, since this one is pointing toward that side, toward negative x, is going to be negative T2x. So the net force should be equal to 0, so that this should be at equilibrium. Then I'm going to say my T3 in this case, my T3 is T3 cos 55 degrees minus my T2 is T2 cos 40. I can shift T2 to the other side, so I'll say T2 cos 40 degrees will be equal to T3 cos 55 degrees. At this point, we have been given FW1. So if we have FW1, meaning we have what? We have T1. Okay? Meaning I have my T1. My T1 is 200 Newton. If I have my FW3, which is here, if I have my FW3, meaning I have my T3. My T3 is 260 in this case. My goal is to find the T2, which is going to be FW2. So I'm going to say T2 cos 40 degrees is equal to T3 is 260 cos 55 degrees. I divide both sides by cos 40 degrees, even here by cos 40 degrees. So my T2 will be equal to, these two will cancel out. I'm going to say 260 cos 55. The answer I find, I divide it by cos what? Cos 40. So I'm getting my T2 to be 194.67 Newton. If I round it off, this will be T2 is equal to 195 newtons. I want you to compare with the answer which have been given here. They are saying the answer is 150. That is wrong. So now they made a mistake here. This question, initially this question, the way it was supposed to be, for us to get 150 newton, the FW, this FW3 is the one which was supposed to be 50 newtons, 200 newtons, sorry. FW3 was supposed to be, let me show you here. Initially, the way the question is, the answer here for T2 is 195 newtons. But the way they were supposed to ask this question, if the answer was supposed to be 150, the FW2 was supposed to be 200 newtons. Let me show you now. If FW2 or FW3, sorry, is 200 newtons, meaning my T2 is also 200 newtons. So if I plug in T2 here, or T3, sorry, T3 to be 200 newtons. So if you say 200 cos 55, the answer you find, divide it by cos what? Cos 40. You'll be able to get your T2 to be 149.75. When you round it off, it's going to be 150 newtons. So for this question, for the answer to be 150, FW2 was supposed to be 200 newtons. So they made a mistake, they swapped. So the way the question is, the answer is not 150, the answer is 195 newtons. Unless if they change, they put FW2 to be 200, that's when the answer can be 150 newtons. So consider this answer to be wrong, the way the question is. The correct answer is 195. Now you can approach this question in a different way. What if I use, in this case it was just direct because I was given two things. In a case where you have two unknown variables, that's when you can use the two equations. Okay, now what if I want to approach this question in a different way? Am I going to get the same 195? Let's see. Let me show you. If I want to approach this question in a different way, like we have said, this is going to be still T1, this is going to be still my T3, this will still be my T1 or my T2, sorry. So I'm going to approach this question in this. I'll say that is what I have there. So I'm going to say, I'm going to have that, then even here I'm going to have that. Meaning, now this is my T2x, this is my T3x. Meaning, here I have got my T3y and also here T2y. At this point now, I can clearly see that this T2x is the one which is going to be sine, because it is opposite. If I want to use now 50 as the angle. Okay, so for y, for x, I'm going to say the summation of x, the forces in x-axis. I have got my T3x pointing toward positive x-axis minus that one since it's pointing toward negative x-axis, which is going to be T2x. This is 0. T3x minus T2x. So this will come here to be T2x will be equal to T3x. Now here I can clearly see that this angle is opposite to that, so that is going to be sine. So I'll say T2 will be replaced by sine theta, will be equal to, even this one will be T3 sine theta. My goal is to find T2. I have everything. T2 sine the angle for the first, for T2 is 50 degrees, is equal to T3 I have. T3 I've been given to say is 260. Sine the angle is 35 degrees. So I divide both sides by sine 50, even here by sine 50 degrees. So these will cancel. My T2 in this case will be equal to, so if I say 260 sine 35, the answer I get divided by sine 50. So you still get 194.67. If I round it off, it will be 195. Like I said, if the answer was supposed to be 150, FW3 was supposed to be equal to 200. So if you plug in 200 here, you'll be able to get 150 newtons. Okay, so I've approached this question using two different things. If you want, you can use the forces in y-axis. For the first one, if you want to use the forces in y direction, still you'll be able to get the same answer. Even here, if I want just to deal with the y direction, I will say the summation of forces in y direction. When you add them, they're supposed to give us 0. What force do we have? We have got T2y plus, since they are all pointing upward, plus T3y. Then minus the T1 which is pointing downward. Okay, this is pointing downward. That's why it's now carrying a negative there. So I'll say T1 will be equal to T2 is now T2. In that case, it's going to be cos, using the second free body diagram which I've just come up with. T2 cos theta plus T3 cos theta. So T1 FW1, which is 2 what? 60, should be equal to T2. We don't know. It's the one we want to find. The angle is 50. T3 we have been given, which is 260. So 260 cos 35. We shift this to the other side, we'll have 260 minus 260. Come on, FW1 is not 260, is 200. So 200 will be equal to 2T2 cos 50 degrees plus, what is 260 cos 35? Is 223 or 212.97, which is the same as 213. If I shift this to the other side, we'll have 200 minus 200 and what? So it's giving me 260. Let's see. I have 260 cos 35 cos 35. Okay, so this is giving me, or I can just do it direct, although it's giving me 213 is equal to T2 cos 50. Okay, now the next thing which we have to do now is okay, so I'm going to say I want to find FT2, so I can divide both sides by cos theta, cos 50, even here, cos 50. So what is 200 minus 200 minus 213? I'm getting negative 3. Negative 3, I divide it by 0.0. I divide it by cos 50. So I'm getting negative. Anyway, I feel like we have made a mistake somewhere, but the answer is supposed to give us the same, even if we are using this in y-axis. Let me restart it from here, from this point here. We said Ty is going to be cos because of the adjacent now in this case. So my T2y, the angle is 50. Yes. Then my FT2, the angle will be what? The angle is 30, or T3, the angle is 35. That is just okay. Then this one which is going down, we have been given that it is what? 200, which is T1 in this case. So T1, 200. T2 is the one we are trying to find. Then we have cos what? We have cos the angle in that case for T2 is 50 degrees plus T3 is 260. So 260 cos 50 or cos 35. Okay, then if I shift that to the other side, it's going to be 200 minus 260 cos 35 is equal to T2 cos 50 degrees. So now when I do 200 minus 260 cos 35, my calculator is not performing well now. So if you do that, then you divide it by cos 50, you are supposed to get the same, which is 194.67. When you round it off, my calculator is not working well, but you are supposed to get exactly the same thing. When you round it off, it's going to be 195. Okay, so that is it for this type of static equilibrium.